Hi everyone, now that we've finished sections 5.1 to 5.4, we're moving on to 5.5, and our learning target today is to be able to graph a linear inequality given an inequality. So that's where we're going to stop for today. We're not going to be looking at situations in context quite yet. And just to give you some context, what we've been doing so far is graphing linear equations. So now we're moving on to linear inequalities, excuse me. So first thing we're going to do is review inequalities, and we did this a few modules back, so this should seem pretty familiar. So if we're graphing x is less than 2, remember with our symbols, we read this as x less than 2. And so if I want to graph that on a number line, remember we start by putting our number 2 on the number line. That's the most important number in our inequality here. And then we said we like to have a number smaller than that and a number bigger than that. Now, there were a couple things that we had to remember. Since my symbol is just less than, remember we said that was going to mean I put an open circle at the 2. And then for less than, remember we said that was like an arrow pointing to the left. So to finish off, I just shade everywhere to the left, and I put an arrow here to show that that would go on forever. So that's a graph of x is less than 2. Now, if I look at x greater than 2, we can see 2 is still our important number. I'm going to put one smaller and one bigger. Now here we still have an open circle. So I'm going to put that here at the 2. But now my arrow looks like it's pointing to the right. So to finish this off, I'm going to shade because everything to the right here is a number greater than 2, right? 3 we know is bigger than 2, 4 is greater than 2, and so on. Now down here, our symbol, let's take a look. This is going to read, if I read this now, this is x is less than still, but less than or equal to 2. So now because of that less than or equal to, we're going to have a closed circle here. So I've still got my 2, I've got a number smaller and a number bigger, but now I have a closed circle. And then the arrow is still shading, or excuse me, pointing to the left, so I'm going to shade to the left. All right, and then last but not least, we have x is greater than or equal to 2. Again, because I have that or equal to, we're going to have a closed circle here. And that arrow is pointing to the right. So my graph on the number line would look like this. So that's a review of what you guys have already done, but a lot of this is going to be really important for what we need to do today. So just as a summary, we're going to have an open circle, right? Meaning this on our number line, whenever our symbol is just less than or greater than. We're going to have a closed circle now whenever we have a less than or equal to or a greater than or equal to. We're going to shade to the left whenever we have a less than or a less than or equal to. And we're going to shade right whenever we have a greater than or equal to. So that's a review of what we've done so far, and now we're going to apply it to graphing linear inequalities. So it says next we're going to be graphing inequalities that have 2 variables. So just like when we've been graphing our linear equations, now we're going to have x and y. And so to do this, we're going to need to combine what we know about lines and inequalities. So let's see how this all comes together. All right, so here I have an example, right? The directions here say to graph the following inequality, right? Again, what we've been doing so far is graphing equations. And so before, this would have said equal to right here. But now I'm going to undo that. Now the difference is that we have an inequality symbol. So when we're graphing, the first thing we want to do is get the y by itself. So I'm going to put that as step 1 up here, is to get y by itself. So I want y all by itself on the left-hand side. And you guys know how to do this. We did a lot of practice with rearranging. So here's what we're going to do. I'm going to draw my line. If I want y by itself, the first thing I need to move over is this 3x. So I have a negative 2y. I still have less than or equal to. And now I have negative 3x plus 8. So the only difference there from what we did with equations is we have this inequality symbol in between. So now to get the y by itself, I need to divide everything by a negative 2. And now here's where we have to be careful. This is going to cancel. But now because I divided by a negative, I need to flip the inequality symbol. So I'm going to make a note that we need to flip inequality because we divided by a negative. And the key here is we divided by a negative on both sides. So now it used to be less than or equal to, now it's greater than or equal to. I have a negative over a negative is a positive, so now I have a 3/2 x, and then 8 divided by negative 2 is minus 4. So I've gotten y by itself. And I'm going to add a note up here. I know we wrote it already, but I want to write it again. I'm going to make a note. Don't forget to flip the inequality symbol whenever you multiply or divide by a negative on both sides. That's going to be really important because that's going to have a big impact on whether your graph comes out correct or incorrect. So we've got step 1 done. We got y by itself. We remembered to flip our inequality symbol because we divided everything by a negative 2. So now we're on to step 2. And step 2 is to identify the slope and the starting point. And I'm going to say the starting point or y-intercept, depending on which form our equation is in. So we're either looking for a slope and a starting point or the slope and the y-intercept. So in this case, hopefully we all recognize that my line is in, I'm going to make a note over here, this is in slope-intercept form. So in our case, our slope is 3/2, and our y-intercept is -4. So I can go ahead and plot those. I'm not going to connect the line just yet. I'll put in my y-intercept here, and then I'll locate some points using my slope. All right, so I've got a few points. Now, step 3 is really important when we're doing inequalities. And again, it's only because it's an inequality and not an equal sign. We have to decide whether to connect our points with a dotted or a solid line. Whenever we were graphing equations, we always used a solid line, but now we have to make a decision. When we're graphing here, if our symbol, and actually I'll make a note to the side here, if our symbol is less than or equal to or greater than or equal to, we're going to use a solid line. If our symbol is just less than or just greater than, we're going to use a dotted line. So in our case, our symbol here is greater than or equal to. That means we are going to use a solid line to connect our points. So I'm going to go ahead and do that. All right, I've got a solid line. And now we've got one step left. What we're really looking for is not the points that are solutions to just this equation, but any point that actually is greater than or equal to this. So the last step when we're doing inequality, let me grab a different color here, is the last step is to decide where to shade. And this is new. This is something we didn't have to do when we were graphing linear equations. We have to decide where to shade. And here's what I mean. We're either going to shade above the line that we just drew, and we're going to shade above if our symbol is greater than or equal to. We're going to shade below if our symbol is less than or equal to. So let's take a look. Again, I'm going to look at our symbol here. Our symbol was greater than or equal to. That means I need to shade everywhere above this line. So think about this way. If this is my line and I look up from the line, that means I'm going to shade in everything that lies above this line. And so once I've done all 4 steps, then my work is complete. I have a line, it's either dotted or solid, and I've shaded in the correct spot. Now here's how you can test, and you won't have to do this every time, but here's what I like to do. Here's how I can test if I've shaded in the right place. Let me grab another color here. Let me grab a test. So I think this is where the area should be shaded. So I'm gonna pick, let's say the point 0, 3, because that's a point that's in my shaded area. So I'm going to test to see if I'm correct. And I'm going to pick 0, 3. Remember my ordered pair, this is my x and this is my y. If I go back to my original inequality, that means I have 3 times 0 minus 2 times 3. And I think that should be less than or equal to 8. So 3 times 0 is 0. Negative 2 times 3 is negative 6. And if I look at negative 6 less than or equal to 8, that is true. That negative number is less than the positive number. So it means I shaded on the correct side. So that's always a quick test you can do to make sure you shaded in the correct side. All right, so that's one example. I'm going to go through a few more with you just so you can get a few more examples before you try the practice. Let me go back. I realized I did not complete this. Again, shading above is if I have greater than or equal to. Shade below is if I'm less than or equal to. Okay, so let's go ahead and see if we can try some more. Okay, I'm going to scroll down here. All right, so again, our instructions, the directions are just to graph the inequality. But again, we've got to go through all of our steps to do that. Now, the nice thing here, our first step was to get y by itself, but you can see that's already been done. So a good chunk of work has been done for us. So the next thing we said we had to do was identify the slope in the y-intercept. Well, this is in slope-intercept form. So we know our slope is equal to 4, and my y-intercept is equal to -3. I've got to be careful with that sign. So I'm going to go down to -3. My slope, I know, is the same as 4 over 1. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I've got some points there. My next decision I had to make, was whether to use a solid or a dotted line. In this case, you can see I've just got a strictly greater than. So greater than means a dotted line. Because it's just greater than, it's not greater than or equal to. And what we mean when we say dotted line is just literally not make it solid. Put some, ooh, that was terrible. Let me try this again. Let's see if I can use a ruler here to help me out. There we go. Rulers are always a good idea. So I'm just going to leave some dashes in my line to break it up. So you can see pretty clearly there, that's not a solid line. So I've got my dotted line. Then the last thing I have to do is to decide where to shade. Since I have a greater than, that means I'm going to shade above the line. So again, if I look at my line and I look, I look up, that means I'm going to shade everywhere that would be on that side of the line. And so this would be a complete graph. And again, I really like to check my answer so I know if I shaded in the correct place. So I'm going to test a point. This looks like 0, 1. So I'm going to test point 0, comma 1. This is x and y. So if I plug in 1 for y, I get 1 is greater than 4 times 0 minus 3. And I want to know, is that true? 4 times 0 is 0, and I get 1 is greater than -3. Positive 1 is greater than -3, so I know I've got a correct answer. All right, we'll do 2 more. I don't think we need to do all 4, but we'll do another one. Let's look at number 2. Now, number 2, I see a nice thing again is that y is already by itself. So they've done step 1 for us. So now I notice this is in point slope form. So I'm going to make a note of that here. This is a good chance to review point slope form. So my slope is just going to be 3. I see that sitting out front, and I can write that as 3 over 1. And then I've got to grab my starting point. Point slope form doesn't give me a y-intercept, but it does give me a starting point. And now here I'm going to be careful because this is x plus 1. That actually means my x was a -1, and then my y is a -2. So I can plot -1, -2. My slope is 1, 2, 3 over 1. Right, sorry. Okay. 1, 2, 3 over 1. So I've got some points there. So I've got my key features. Now I need to decide, is this a dotted or a solid line? Well, here I have a greater than or equal to. Because of that equal to, now this is going to be a solid line. So I'm going to try again to use my eraser, or not my eraser, my ruler. It's a little weird on the screen, but it helps me be a little better. So I've got a solid line. I'm going to put my arrows on either side. And then last but not least, I have to decide where to shade. That's my 4th step. So my sign was greater than or, whoops, what did I do there? Not shapes, I want to be in drawing. My sign, my symbol, inequality symbol, was greater than or equal to. So yet again, we're going to end up shading above the line. And so if I look up from the line, that tells me that I'm going to shade everything here above the line. Okay, and that one's done. All right, let's do one more. And we'll pick number 3 because we finally have a less than symbol here. So let's do number 3. Now in this one, step 1 is not done for us. So we need to go ahead and do that. And remember, step 1 was getting y by itself. So first I'm going to subtract 2x from both sides. So I get 2y is less than a negative 2x plus 10. And then I'm going to divide. In this case, we're dividing by a positive 2. So we're not going to have to worry about flipping any symbols. So now I just get y is less than. I have negative 2 divided by 2 is a negative 1x. And then 10 divided by 2 is 5. So I've got y all by itself, which is good. Now we're going to go ahead and pick out our slope and our y-intercept. So our slope here is negative 1, which we can write as negative 1 over 1. Our y-intercept is going to be 5. So let's see, y-intercept is up here at positive 5. Now my slope is negative this time, so I'm going to be careful to go down 1 and over 1. Down 1 over 1. I can keep this up. All right, so I've got a good set of points. Now I have to decide solid or dotted. Well, our symbol was less than. Since there's no equal to, this is going to be a dotted line. So I'm going to connect my points, but again, I'm not going to make it a solid line. I'm going to kind of put some gaps in here. So just like this. So leaving holes in there to show really clearly that that's a dotted line. And then last but not least, I have a less than symbol. So that means this time we're finally shading below the line. So if I look at my line, now I'm not looking up, I want to look down. And so everything on that same side here is going to get shaded in. And that problem's done. Now this one I want to check. I want to make sure I really was supposed to shade down there. So it looks like 0, negative 2 is a nice point down here in this blue area. So I'm going to test 0, negative 2. Let's see what happens. This is my x and this is my y. So I'm going to go back to the original. So I've got 2 times 0 plus 2 times a negative 2. I want to know, is that less than 10? Well, 2 times 0 is just 0. 2 times a negative 2 is negative 4. And we know negative 4 is less than 10. So we got it in the right place. All right, so I know there was a lot to this. Hopefully that's all pretty clear and makes sense. You'll have some time or some opportunities to practice this in the Ready, Set, Go, but please reach out if you need more support getting these problems done. Uh-oh. Let's see. Sorry about this, guys. I need to get back to end the video. Where is it? Here we go. Maybe we can stop from here.